Video's on, zoom out a bit. There we go. So this test, we started the content at the start of term 2. It's a very short unit, it took us about 3 weeks, and it's explicitly just chapter 7. In 7a, we learn about the difference between those two types of variables: continuous, existing on an interval, and discrete, variables that you count. Now, continuous we then shoved into chapter 8 and 9. That's where we really explored continuous random variables. And that means chapter 7 was a focus on the discrete ones, the variables that you count. And so we had discrete probability distributions. So these, notice how these are probability distributions that have an exact value occurring. They're not continuous, they're not a curve. In the histogram graph there, we can see clear spaces between them separating the events. We just have a few different types of probability distributions. So we have a uniform discrete is one where each outcome is equally likely. So rolling a fair dice, each outcome is 1 out of 6. We've got the mode is the event with the highest probability. The median is the event that corresponds to a probability of 0.5 when the previous possible events are added together. And we have the probability of all events adds to 1. Then in exercise 7c, we learn about the average result, the expected value from a probability distribution. And in 7c.3, we look at fair games, which is a way to apply the average result. On to D, we're learning about the variance and standard deviation. Then we have some new variable y related to the variable x and its properties in 7e, and then 7f goes on to Bernoulli distributions, with 7g being binomials. Very good. So we'll go through these questions together. We have a policeman inspected the safety of tyres on cars passing through a checkpoint. The number of tyres which needed replacing on each car following the distribution below. So if you need 0 tyres replaced, that's 68% of cars, right? Part A says determine the value of K. Well, we know that all of these probabilities add up to 1, right? So I've got there 0.7, 0.9, I've got K's 0.04. Okay. Now that just needs to be a statement. There's no need to show any working out there. All probabilities add to 1. Part B, find the mode of the distribution. The mode is the event that has the highest probability, and so the mode is 0. Most cars, the most frequently occurring event was that a car needed 0 tyres replaced. Find the probability of x being larger than 1 and interpret. So now this is where x being larger than 1 is not the same as x being larger than or equal to 1. All right, if you think we can have 0, 1, 2, 3, or 4 tyres replaced on a car, and it's saying more than 1, it means these events here, right? So it's event 2 plus 3 plus 4, or 1 take away both of those added together. So what's that going to be? We've got 0.0, 0.1, 0.12. So that's the probability that you need 2 or more tyres changed. All right, we've got Ernie's going fishing. He catches 0, 1, 2, or 3 fish with the probabilities shown alongside. On average, how many fish would you expect Ernie to catch? Now what we'll do here is we'll do this one manually, and then I think in the next one we'll look at how we can use our calculator to determine the mean, median, and mode as well. So, E of x, the mean of a distribution, they are the same thing, and it's the sum of each event multiplied by its respective probability. So we have 0 times 0.17 plus 1 times 0.28 plus 2 times 0.36 plus 3 times 0.19. And we'll evaluate that.
1.57.
Thank you, 1.57. Okay, so what this means, it's an average result. So on average, based on the probability distribution, we expect Ernie to catch 1.57 fish per trip. Okay, Given the distribution alongside, determine the mean, median, mode, and standard deviation. So this is where we're going to use our calculator, and we're in Stat menu. And what I want to remind you is how to operate the settings. We have information in list 1, that's going to be the events, and we have information in list 2, the respective probabilities. And so we have event 1, 2, 3, and we have probability 0.3, 0.4, and 0.3. So if we list those out, and I'll just explain the two settings, and I have this written down on our calculator. So 1, 2, 3, and 0.3, 0.4, 0.3. So the first thing we're going to do is we're going to press Calc, and we're going to check our settings. So we press Set. Now, when we have information in two lists, we want one there to say list 1, and one var frequency to say list 2. Okay, so the first two things listed should say list 1, list 2. If it says list 1 and the number 1, you need to change it. List 1 and the number 1, that's for when we only have data in one column and we want to determine the mean, median, and mode of that one single data set.
Will we have to change that setting?
I've never seen you need to evaluate mean, median, and mode for a single data set. Hasn't popped up since I've been teaching the course, but you need to know it's part of the course. So. All right, and I've got an A4 sheet of calculator instructions. They're on the OneDrive, but I might print it off for you at recess today so we can talk about those, and it does include this information. All right, so we've got that set, and so then it's just a matter of exiting out of our settings and calculating the one var. All right, and what we can see is we've got the mean is 2, and you scroll down and it presents all of the other results for you as well. The median is 2, the mode is 2, and the standard deviation is 0.774.
What should the rest of the settings be? Because I'm getting different stuff to that.
Interesting. Those are the only two settings we need to change. I might come have a look. So I've got mean, median, mode, and standard deviation. Do you need me to have a look at it?
Yeah, sorry, I got it.
Thank you. Very good. Now, we did all these on your calculator, and remember, in the exam, you've got limited time. If you can do it on your calculator, do it on your calculator. Preserve your brain power. But still, there are circumstances in previous exams where it said, show that the standard deviation is this, which means you do need to use the standard deviation formula. So all of these you do need to know how to do manually, but if given the opportunity, encourage you to use your calculator. Okay, number 4, we have Dominic is the door-to-door salesman. Each day he earns $100 plus $25 for each sale made. From previous experience, he knows that the number of sales per day follows this distribution. Wants us to find the mean, the variance, and the standard deviation from this distribution. So we'll go straight to our calculator. So this is for question 4. And we'll input the events. We have either 0, 1, 2, 3, 4, 5. And for probabilities, so our mean is 1.61. All right. And our variance is frequently not displayed here. We need to calculate it manually. So our standard,
The mean.
that's the mean. Yep.
I got 1.85.
Yeah, I got 1.5.
I reckon 1.85 is correct. I haven't put something in properly. So that's, I've got a probability of 0 for number 4. It should be 0.1. Yep, 1.85. Okay, and then our standard deviation is 1.314. And the variance is the standard deviation squared. Alright, so it's going to be 1.314 squared. We'll just leave it like that for now, I think.
1.72.
Thank you. Okay, so that's part A. And then for part B, we're asked, suppose Y is the amount of money Dominic earns in dollars per day. Write Y in terms of X. All right, so we're told in the question that he earns $100 per day plus 25 for each sale made, where X is the variable for the number of sales. All right, and so then it's saying, hence find E of Y. So I'll just flick you back on the previous page, so literally just on the page opposite. We've got 7E, the properties of AX plus B, and we're just going to use this property here, that the E of AX plus B, the expected value of AX plus B is equal to A times the expected value of X plus B. So what this means is if we want to find the expected value of Y, where Y is 100 plus 25X, it's going to be 25 times the expected value of X. All right, and our expected value of X is the mean, 1.85, and then plus the B, plus the 100. Okay, so that's going to be, suppose Y is the amount of money he earns, that's the variable Y, and if we've found the expected value of Y, that's how much he's making each day, right? Thank you, $146.25. Very good. And then we can use those other formulas there to find the variance of Y and the standard deviation of Y. So the variance is just A squared times the variance of X. All right, so in this circumstance, it's going to be 25 squared times the 1.72. And then the standard deviation is just the square root of that. Like, we don't have to link it directly to the formula we've just done.
1075.
Repeat that, sorry.
1075.
Thank you. And yes, standard deviation will be the square root of that. So I might just leave it like that.
32.8.
Yep. Cool. All right, so that's number 4. Just flip the page. Okay, now we're on to a Bernoulli variable. So consider the spinner alongside. Let x equal 1 if the outcome is red. It's funny because it's not red. X equal 1 if the outcome is red, and x equals 0 if the outcome is white. Okay, explain why this is a Bernoulli variable. So Bernoulli variable has 2 properties, all right? We have one trial, all right, so we're repeating the experiment once, and we have clearly defined success equals 1, failure equals 0. So that's what we can say for part A. This is 5A. So we have one trial, clearly defined success and failure. Very good. Okay, now on to part B. Find the mean of X and the standard deviation of X. So we can flick back to the Bernoulli properties, but we can see that the mean of X is just the value of P, the probability of success, which is 0.75, and the standard deviation is the square root of P cubed. So that's going to be the square root of 0.75 times 0.25. Very good, so that's number 5, that's a pretty good one. All right, and then we're on to the binomial distributions. Records show that 6% of the items assembled on a production line are faulty. A random sample of 12 items is selected with replacement. Okay, the replacement's to tell us the binomial distribution applies. Find the probability that none will be faulty. B, at most 1 will be faulty. All right, so let's just start with part A. And we might cover this in a few different ways. That is how a couple of ways we can answer this. So the probability that none are faulty. Now the first thing would be to say, well, we've got 6% on average are faulty, which means the probability of it not being faulty is 0.94, right? And we're picking out 12 items. So it's 0.94 times 0.94 times 0.94 12 times, right? 0.94 to the power of 12. Okay, it's a conditional probability. It's conditional on the first one not being faulty, the second one not being faulty, the third one, and so we could evaluate it like that. Another way that we might understand it, all right, is that it's the probability of having 0 faulty ones selected. So this is a BPD calculation. Actually, first let's just do the binomial calculation and then we'll list the BPD calculation. So I'll write up the general formula here. Alright, so what this means is the number of ways we can have k successes from n trials, the probability of success to the number of successes, the probability of failure to the number of failures. And so what we're talking about in this circumstance is we'd have 12C0. You evaluate that, it's going to be 1. And then we have multiplied by the number of successes. Now in this circumstance, we've defined a success as a faulty one. So we have 0.06 to the power of 0 times 0.94 to the power of 12. All right, so we can evaluate that on our calculator. We need to understand the link between here and the binomial distribution formula. And of course, this is a BPD calculation. It's 0 successes, 12 trials, and the probability of a faulty one is 0.06. Okay, what's the probability that none are faulty out of 12 selected? So 3 ways of achieving the same thing. These are the same statement. Why? Because that's 1, and so you're just left with 0.94 to the power of 12. Okay, so that's part A. Okay, part B, at most, 1 will be faulty. So if we think of how many could be faulty, 6, 7, 8, 9, 10, 11, 12. They're saying at most 1. So what it means is we have between 0 and 1 faulty. So we could do the probability of 0 plus the probability of 1, but anytime we need to consider multiple events, that's straight to a BCD calculation, isn't it? It's the probability of between 0 and 1 being faulty. Remember, those boundaries are included. 0 and 1 being faulty out of 12. So BCD, lower, upper, number of trials, and then probability of the event occurring, 0.06.
0.84.
Thank you. I didn't even evaluate this one either.
0.476.
Cool.
0.84.
0.84. That's great. Okay, part C says, what about at least 2 being faulty? So if we're saying at least 2 being faulty, it means this event. All right, so that's for part B. So then for part C, so we could do the BCD of between 2 and 12 being faulty, but we should also see a link from what we've just done. All right, we saw that the probability of it being less than 2 was 0.84, which means the probability of it being 2 or more is 0.16. All right, because the probability of all events adds to 1, and so the events outside of this section, that's how we can generate that. Okay, and then for part D we have less than 4 being faulty. So what that means, if it says less than 4, it means literally less than 4. So it means between 0 and 3. So it's a BCD from 0 to 3.
0.9.
Thank you. 0.986. Splendid. So that is 0.996. So that's a good recap of discrete random variables. Yeah, I reckon I'll stop there.